Hi, in this video we're going to explore the NurbsCurve class in RhinoCommon. So in order to do so, we'll head to the Rhino Geometry namespace and we'll search for the NurbsCurve here. And the NurbsCurve is actually like the curve, but you can construct a NurbsCurve directly using a degree and a number of point counts, but it will still be an empty NurbsCurve. And in order to create a NurbsCurve, you have to use the methods, and here we'll find the create methods which can create some. So we can create control point curve. We can, I think that's it, that's what we're going to use, the control point curve. And let's try that. If we check it, we only need to use a points list and a degree, and to do so it's a static method, and here we can create some points and set them here, 1 2 3 4 5 6 for example, add them and call them points, and this will be the control points of our NurbsCurve. So in order to create a NurbsCurve, we'll write the class name, call it curve A, and that will be equals to NurbsCurve dot create control point curve, and here we'll pass the points input and the degree of the curve. Let's call it 3 directly and call A equals curve A, and let's run that. And we have a problem because we forgot to make this a list axis and we didn't configure the type hint to point 3D, and still there is a problem. Let's check it out. Here it says that cannot implicitly convert a Rhino geometry curve to a NurbsCurve. So the results of this object is a curve. Let's check this out. Here it gives us a curve actually and not a NurbsCurve. So let's just try to make this curve and run, and here it goes. So this is a big difference between this control point curve and the interpolated curve that we created in the video before this one, because the control points actually, those especially in the middle, fall outside the curve. They're not on the curve. So this is called a NurbsCurve or a control points curve. We can almost do all the methods and all of the properties of the curves on this curve, so we can get its degree, we can change the domain, we can check if it's closed, or a lot of things. We can get access to the control points of this curve, and let's check this one. So let's try this property. So apparently it's not a static property, so we'll call curve A dot points. It's not like this, maybe because it's a curve A, but if we turn this curve, NurbsCurve curve B equals curve A dot to NurbsCurve, maybe this will work. Let's try now and find what we were trying now to actually get the points. So maybe if we type here dot points, yes, it works, and the points shall be a class, but we can use the var. It should be a list of points. Actually, if you want to do it right, if you want to write it right, we need to copy this term, which is NurbsCurve point list, because this is the data type of the points, I guess. So let's try it and see if it works, and call it points, and that will equal to curve B, and try and see. No, there is a problem. Okay, here the issues that show that there is no NurbsCurve point list. So maybe if we just create a point 3D list, probably this will work, I think. So list of point 3D points, and try now. Yep. So there is a problem in line 57 that says, yep, here we chose a name that's similar to another variable that exists in our script, which is points. So let's just call it points2 and run the script, and another error will disappear. Now it says that this is not used as a method, so if we remove this, yep, it shall work. So if we again paste this and try, no, still problem. So apparently if we just write variable, because we didn't get what is the variable type, data type that we need, if we just type variable, it will give us the result until we figure out what is the data type. But I think if we open this, we can get the data type. So it's a NurbsCurve point list class. Actually, it's not a data type, it's a class, and it's under the collections. So maybe it gives us an array, I'm not sure, but let's just keep it this way, and let's get our points. So if b equals points2, here we can get the control points of the curve, which are 6 that we actually chose there. And here we find that the type is called control points. So maybe if we try and call this control point, does it work? No, the control point, no. Let's keep it var, rotating to variable, and here we can list item, and from 0 to 5. If we do so, we can start controlling getting our control points, which are not okay. So if we call this geometry, maybe this will work. Nope. Okay, 1 second please. Okay, so apparently when we try to call this as a list of point 3D and run it, it gives us an error that says that we cannot convert the type rhino.geometry.collections.NurbsCurve point to a list. So now we can figure out this type. So we can just type here, instead of list point 3D, we can just type rhino.geometry.collections.NurbsCurve point list. And if we run this, now it works. So we figured out the variable or data type, and this was our first thing. And now the problem appears is that we are not showing here any points, because the output of this very program is a rhino.geometry.control point. It's not a point 3D. So it does not even appear in Rhino, and it's something called a control point, and not that does not belong to the point 3D class. So searching a bit in the RhinoCommon API, I found that this NurbsCurve pointless class, we can get a certain point at it using a getPoint method. This getPoint method will work as follows. So it gives us it returns a true or false value, and we can output a certain point. So let's try it. If we, let's say, want to get the second point, the second control point, then we can say points to dot get, not dot get, it will be dot, sorry, yes, dot get point. So points to dot get point, and here this should be working. Yep, we need to add an index, so index 1, and we'll say out point B. And if we add here another output and call it point B, now we can get the control point at this, but we have still an error. I'm very sorry. So point B, yeah, we have to initiate the point B at first. Out point 3D point B. Let's try this. Nope. Okay, let's create a point 3D point B. Okay, this works actually, and the C returns a point 3D now. So if we plug it here, we can get this point exactly. This is actually a very, very long way, and I don't really know why would I want to get a control point if I'm actually inputting the control points. But anyway, this was just like trying to understand the RhinoCommon and trying to think of if any problem appears, if there are any errors, how can I address them, how can I use it by reading the RhinoCommon really well and understanding the meaning of what a method returns and which class shall I search in, and what does a method outputs, and so on and so forth. So again, we can also find the tangent at the end and the start. We can get the closest point to a curve on a curve, closest to some point. Let's try this out, and again, let's open the RhinoCommon and find and we're going to do this using a test point, and we want to output the point. So a closest point with a test point and a parameter here. So let's check this out with a double maximum distance, or we're just going to out a double. Let's just use this method which returns a boolean, and here we're going to say, so boolean a equals our curve, which is curve a dot point at, and here we need to I'm sorry, dot closest point, and here we need to add a test point. Let's call it test point, and we're going to out the parameter where the point is actually sitting on, so we'll out t, and before that we need to initiate the t. Okay, and now we can find the point at a certain parameter which is t. So let's just get and say point 3D closest point equals curve a dot point at this double, which is t. And now we need to find this closest point. And the code shall go well if we add here a test point to the inputs. So if we call this a test point and make the type hint a point3D and add a point here, this shall work. Let's set one point, probably anywhere, and we have an error. Let's check it. The name D does not exist yet. We need to add this D, and now the code works. And if we connect this point here, we find that this is the closest point to this point, and if we move it, we can get the closest point on the curve to this point. Okay, what else can we do here? We can create a NURBS curve from a line. We can create it from fit points. We can create it from an ellipse just by passing those geometries to this method. And we've seen the divisions. Let's try one last thing, which is offsetting the NURBS curve. And to offset a NURBS curve, all we have to do is, it returns, of course, a curve also. Let's just make sure. What data type does it return? And it returns a curve array, not a curve. So we have to type here curve array offset curve equals, and as it is not a static method, we'll call it using our object, and here we'll say dot offset, and it needs a plane. So let's say it's the world XY plane. Okay, or we can do it by using a point3D and a vector. Let's just try using it by the plane. So we'll say here plane dot world XY and a double distance, let's say 5, and the tolerance, let's call it 0.001, and the curve offset corner, let's make it smooth, for example. And now let's see what we get. So E equals offset curve, and let's add E to the outputs here and check our offset curve. Yep, here it is. Okay, so let's change the style to none and try. Let's make it like 10 distance, or maybe 20. Yeah. So of course an offset NURBS curve will change in the matter of how its control points move, actually, or offset. But maybe if we change this, if we want a cleaner offset curve, we might choose the other way, which is a point3D. Let's call it point B. Okay, that we or not point B, but it will be this point that we added here, the test point, and let's check here. Yes, so our test point, a vector 3D, so new vector 3D that will move in the x, in the y direction, so 0, 10 and 0. So this is our vector, and we need the distance, which will be 20, the tolerance, and the corner style. So curve offset corner style dot none. And let's try outputting this and check what happens. Okay, it actually gives us the same exactly, the same curve exactly. So offsetting this curve does not give me a quite nice offset. Let's try it in Rhino. So if we are going to offset this curve, which is A, it gives me actually a quite nice offset here. So give me a moment to check what's wrong with this line of code that does not give me the same offset that happens here. Okay, so trying it, our problem was actually the distance. So in our offset curve, if we made the distance 10, it will show us the same exact problem that happened because of the curve shape. And when only trying to change the distance in the very same code using the test point, a vector, a normal vector, which is vector3d.z-axis, the distance as 1, it actually worked well. So if I remove this, this is our curve here. And if we change the point location, it will give us the offset to the other side and so on. And actually, if we change the distance to 2, it will still give us a clear offset. And this kink happens actually because this curve is really maybe this point. If we change this point, no, not actually. Maybe if we try to change the corner style to smooth, this will work. Let's try it. And smooth starts with a large S or capital S. No, not actually working. Dot round, maybe. Let's try it. No, it's not actually doing the same thing. And the offset actually gives us the same problem here. I think no, negative. Let's call it using a number, -1 to 2. And yeah, the offset on this side gives us this kink, but if we move this point here, it gives us a smooth curve. So it depends actually on the shape of the curve. Actually, I'm exploring with you these problems, yeah, and I hope that these very errors that happen with us are a better way of learning and a better way to find out and to really get the knowledge you need about RhinoCommon, how to use how to use it and how to find every solution for your problems inside this very website without needing to go search on Google. So just the practice will give you a sense of how to solve any problem that happens in your script. Again, this time I'm really sorry for making this video long and having all of those errors, but I hope that those errors really helped you in understanding more how to use RhinoCommon. Thank you and see you in the next video.